Hello everyone, I welcome you all to this class. This is mathematics class, and today we are here to continue with the topic we introduced in our previous class, limits of functions. So I told you that I will be showing you how to evaluate limits of real value functions with some examples. Now, the one we are going to consider in this class is a situation whereby you are evaluating limits of function, and if you substitute the points at which you are evaluating the limit at, then if you are getting 0 over 0 as your result, that 0 over 0 is not an answer, so it is indeterminate expression. So if you get an indeterminate expression, so how do you evaluate such limits? So we are going to do that with the help of Hopital's rule. So this Hopital's rule is saying that assuming that g and h are two functions such that g at c is 0 and h at c is what? 0, and g prime at c and h prime at c, both of them exist. That's h and g are differentiable at that point c, such that the h prime at c is not equal to 0. Then limit as x goes to c, as x goes to the point c, of g of x divided by h of x is equal to g prime at c divided by h prime at c. So we are going to evaluate some limits that will give you 0 over 0 if you substitute the points using this Hopital's rule. So in this example, we are to evaluate the following limits. The first limit, we are going to write the question down. If we are going to use the method we used in our previous class, the method is you substitute the point directly, right? That's how to evaluate the limit. So x is going to 4, right? You substitute 4 for x, replace x with 4 anywhere you see x. So this will be square root of 4 minus 2 divided by what? 4 minus 4. So I'll put x for what? 4. Put x for 4. So this will give you what? Square root of 4 is what? 2 minus 2 divided by 4 minus 4. This is 0 over what? 0. Right? 0 over 0. That's what we got. So it's an indeterminate expression. So this is 0 over 0 is not an answer. So we use this Hopital's rule. So this will give us the limit as x goes to 4 of square root of x minus 2 divided by x minus 4 will be equal to. So the numerator is your, look at this. What the function you have at the numerator is your g of x. So g of x is square root of x minus 2. Whatever you have at the numerator is your g of x. Then whatever you have at the denominator is your h of x. That's x minus 4. So the answer will be the derivative of g of x at what? C. So you differentiate the numerator, then you differentiate the what? Denominator, and substitute the points after that. So let's just differentiate first. So we are going to have limit as x goes to what? 4 of the derivative. What is the derivative of this? We differentiate this. So we want to differentiate. So let's differentiate numerator. Numerator is square root of x minus 2. Let's differentiate square root of x. Square root of x is the same thing as x raised to power 1 over 2. Then if you want to differentiate it, you bring the power. What is the power here? The power is what? 1 over 2. Then you write x and remove 1 from the power. 1 over 2 minus 1. That will be 1 over 2x raised to power. Half minus 1 will give you what? Minus half. So this is half of x raised to power minus half. That's it. I'm doing the derivative of numerator. If you differentiate, minus 2 is 0. Derivative of constant is 0. Then minus 0. All divided by, if you differentiate x, you get what? 1. And if you differentiate minus 1, derivative of a constant is 0. So you are going to have what? 0. We are going to substitute the point. What's the point here? 4. Because x is going to 4. So we'll substitute the point. So we have 1 over 2 multiplying 4 raised to power minus half minus 0, all divided by 1 plus 0. So I have substituted x for 4 here. So this will give us 4 raised to power minus half. If we use indices, this is the same thing as, so let's write half, 1 over 2 we have here. Then this is the same thing as 1 over 4 raised to power half. If we use indices, we will just remove this minus, then divided by 1. So that will be 1 over 2 multiplying 4 raised to power half is just square root of 4, which is what? 2. So we have 2, then we have 1 over, we're having 1 over what? 2 divided by 1. That will give you 1 over 4 divided by 1, which is 1 over 4. So the answer to this is 1 over 4. For the question B, we have limit as x goes to pi of sine 2x divided by x minus pi. So this is what we have. So what are we going to do? We are going to substitute the point. X is going to what? Pi. We'll substitute the point. So we'll have sine 2 pi, because we're having 2 times x, and our x is what? Pi is going, so we'll have what? 2 pi. 2 pi, then all divided by, we replace x with pi. Pi minus pi. What is sine 2 pi? That's 2 pi is 360. So sine 2 pi is 0. Then pi minus pi will give you 0. So we got 0 over 0. So we use the Hopital's rule. So that limit as x goes to pi of sine 2x divided by x minus pi will be equal to limit as x goes to pi. Then we are going to, because we got 0 over 0, we are going to apply the Hopital's rule. So the numerator is our g of x and the denominator is our h of x. We differentiate and substitute the point. That's what the theorem is saying. So if you differentiate this, we want to differentiate sine 2x. So you are going to differentiate the angle of sine. What's the angle? 2x. If you differentiate 2x, you are going to get what? 2. Use the result and multiply the derivative of sine. If you differentiate sine, you get what? Positive cosine. So we have positive cosine 2x. So the result of the derivative is 2 cosine of 2x. All divided by, then you differentiate the denominator. If you differentiate x, you get 1. And if you differentiate minus pi, pi is a constant, you get 0. So this is what we have. We can now substitute the points now. X is going to what? Pi. We replace x with pi, so we have 2 cosine of, instead of 2x, it will be 2 pi. Then divided by 1 plus 0 is 1. Then we now evaluate. What is cos 2 pi? That's cos 360. Cos 360 is 1. And we have 2 multiply cos 360. That's 2 multiply 1, which is 2 divided by 1. This gives us 2 as the result. Okay, thank you so much for being part of this class. We'll be solving more of this kind of question in our upcoming classes. Thank you.